Today, once again, I welcome you all in the session of Dr. Dilip Vasava, Assistant Professor, Department of Chemistry, Gujarat University, Ahmedabad, India. Dr. Vasava previously associated with St. Xavier's College, Ahmedabad, and presently working in Gujarat University. A quality-oriented professional with nearly 24 years of experience in teaching and training. Apart from this, he is conducting various workshops, conferences, seminars, and trainings in various high schools and colleges, as well expertise trainer for students, youth, untrained peoples, farmers, and professionals. He has qualified Gujarat State Eligibility Test for Assistant Professor in Chemical Sciences held in September 2019. He has broad association with St. Xavier's College, Ahmedabad, Kadi Sarva Vidyalaya Kadi, Board of Member of Studies, St. Xavier's College, Member Board of Studies, Swarnim Startup University, Gandhinagar. Additionally, he is in association with professional bodies as life member of Indian Council of Chemists, ICC Agra, and life member the Society of Polymer Sciences, India, as well life coach Landmark Education, USA. He has 16 research publications in various international national journals, 2 books published in international publication, 3 conference proceedings, and 6 patents under examination. In addition, he has attended more than 50 workshops and seminars in different states and cities. 1 PhD and 2 MPhil students has been awarded under his guidance, and 4 PhD and 1 MPhil scholar are ongoing. He has completed 2 minor projects funded by Gujcos, Gandhinagar, Gujarat, and UGC MRP, New Delhi. Awarded as Best Life Coach in Self-Expression Leadership Program, SELP, in 2016, Landmark Education, USA. Appreciation Award for Social Activity in 2019 from Sangat, Ahmedabad. He has delivered more than 50 invited talks in conferences, seminars, workshops, and coursework. Worked as organizing secretary and convener for the international, national, state level conferences, seminars, workshops, quiz, elocutions, and other activities. He is also an active coordinator for NET/SLET Remedial Education Program in Department of Chemistry, Gujarat University. He is reviewer in various international publications like American Chemical Society, Bentham Science, Elsevier, Sage Publication, Polymer, MDPI, Switzerland, and many more. In addition, he is also a reviewer for Research Grant Proposal, National Science Academy, Poland. His thrust area of research includes high-performance polymers, biodegradable polymers, nanotechnology and nanocomposites, liquid crystal, green chemistry, and organic synthesis. And presently, he is doing an active coordinatorship for online refresher course in chemistry. Thank you.
Good morning all. First of all, I would like to thanks to Dr. Jagdish Joshi sir, Director HRDC Gujarat University, for giving me an opportunity to be a coordinator of online refresher course in chemistry. I also thankful to HRDC for giving me an opportunity to deliver a talk. Thank you.
Namaskar. Today I will share my idea on principles of green chemistry and applications of the green chemistry in organic synthesis. So, welcome to this session. So basically, green chemistry is a design of any of the chemical compound, including the process, and the ultimate goal is to eliminate the use or generation of the hazardous substances. So it applies the entire life cycle of the chemical compound that is produced. And when we are saying that the entire life of the chemical compound, means it can be from design to degradation, and the effect of it should be minimized. And that is why we could say that the green chemistry is the sustainable chemistry. It is ultimately the philosophy of green chemistry can apply to all the fields of the chemistry, and it is actually the innovation. It is actually the scientific solution to the real world environmental problem that world is suffering today. So it is not only to reduce the pollution or hazardous effect on the environment, but it is also to avoid the use of the hazardous material. So I could say that it should be prevented at molecular level. Then only we could save the environment. It is not only the cleaning of the pollution. It is not only to reduce the hazardous products. It is not only to modify the present processes and methodology and technology, but it is also the cleaning of mindset to use the hazardous chemicals. Now I can say that a day is consists of 12 hours. A year is having 12 months. Total zodiac are 12. And in some of the society, ritual of mourning is carried out after the death of the person. That is also after 12 days. So I don't know, but probably the scientist has given the 12 principles of green chemistry by connecting this. I'm not sure. But what are the 12 principles of the green chemistry? That is 1. Prevent waste. 2nd, maximize atom economy. 3rd, design less polluted chemical synthesis. 4th, design safer chemical products. 5th, utilize safer solvents and reaction conditions. 6th, increase energy efficiency. 7, use of the renewable resources. 8, avoid chemical derivatives, blocking of the functional groups. 9, to utilize the maximum catalyst. 10, design chemical and products to degrade after use. 11, analyze the real time to prevent the pollution. Last, that is 12, to avoid the potential accidents. So these are the 12 principles of the green chemistry. According to the first principle of green chemistry, leave no waste to treat. So the prevention is the best remedy than clean up the waste after use. So we can modify or we can develop a chemical method in such a way that it prevents the waste. Second principle, that maximize the atom economy. So we could say that all the atom must converted into desired products. So all the starting material that is utilized during the reaction should be converted into the desired product. That is the ideal condition, and that includes the starting material, the solvents, etc. Here, the concept to calculate the percentage yield, percentage selectivity, and percentage atom economy is given. So percentage atom economy is equal to 100 into relative molecular mass of desired product divided by the relative molecular mass of the reactants. So I can give you very simple example about this, and here it is the Bryan's reaction. What is it? This is to prepare the ibuprofen, and it is the reaction that is given by the Bryan's. But what is the drawback of it is it produces the 3 bottles of waste while producing the 2 bottles of the ibuprofen. So the percentage economy is only 40 percentage economy. So all the starting material that is utilized, that is not converted into the desired product. So later on, the another green concept, green reaction is developed, that is the Maloney's reaction for the synthesis of the same ibuprofen, where the starting material is remain same, but the method is modified, and accordingly the intermediates are also modified. So here 3 bottles of ibuprofen is produced and less than 1 bottle waste is generated. So we could say that the maximum starting material is converted into the ibuprofen. So the atom economy is 77%. So these are the formula to calculate the percentage atom economy. So this one is calculated for the first reaction, that is only 40% economy, but here in the green reaction it is 77%. According to this principle, the third principle, the design of the synthesis method is in such a way that it does not generate any lethal or toxic products either to the human or the entire environment. So being a researcher, being a chemistry teacher, it is our job to ensure that what stuff is going to the flask, because our aim is to utilize all the starting material to the product. So here I had given an example to synthesize the polymer. So with the starting material of the bisphenol, the polymer is synthesized by using the phosgene. Now phosgene is very toxic material, and during the process CH2Cl2 is also utilized, and the product that is obtained, that is contaminated with the Cl impurities. But now the safer method is this, and the starting material is same, but in place of the phosgene, diphenyl carbonate is utilized, and also in place of the CH2Cl2, phenol is utilized, and same polymer is produced. So here we could say that the phosgene gas that is hazardous, that is not utilized. Also CH2Cl2 is also not utilized, and high quality product is obtained. It is required to produce the safer chemicals, so that safer chemical should not harm to the environment. So being a chemistry professor, it is our job to understand the whole mechanism of the reaction, the hazardous relationship, and then we could utilize the chemicals for the synthesis of the desired product. So our planet is the precious, and we could utilize the safer product for ourselves as well as for our planet. Along with that, along with the synthesis method, we are using the solvents or additives, auxiliaries, catalyst. So the auxiliaries that we are utilizing, that is also should be environmental friendly. It is advisable that we should avoid the solvents, we should avoid the additives, but if it is required during the synthesis, then we should utilize the green. And nature has given enough. Nature is giving the green solvents in the form of the ionic liquids or in the form of the green solvents. Now it is our job to design the green method. The key issue of the 21st century in the world is the energy. Being a chemist, it is required to understand the energy, and here I can say that enthalpy and entropy. We could train ourselves, we could understand the delta H in the Gibbs free energy equation, heat of formation, heat of vaporization, enthalpy, exothermic, endothermic reaction. So this energy relationship should be studied. And it is advised to carry out the reaction at room temperature or at lower pressure. So ultimately it is the critical aspect to design the synthesis method. The another aspect of green chemistry is to utilize the renewable feedstock. So now this is the time to have the collaboration with the different experts. It is the collaboration between the different disciplines, including biotechnology, agronomy, toxicology, physics, engineering, and other fields, because it is required to utilize the feedstock, that is the renewable, and mainly that is the agricultural products. Last year, you are familiar with the issue of Delhi, that pollution was created. Now it was not only due to the burning of the renewable feedstock by the farmers, but that may be one of the reason. So by using that, by converting that feedstock, it is possible to degrade the pollution. Here the cornstarch obtained from the corn can be converted into the packing material. Now, according to this principle, reduce the derivatives, and ultimately if we reduce the number of steps, automatically the intermediate will reduce. So that can be possible by the deprotection and protection concept. So while designing the synthetic method of the target molecule, we are having the concept of the retrosynthesis. So while designing the method, it should be considered that minimum functional group can be protected such that minimum intermediate can be produced during the reaction. According to the 9th principle, the uses of the catalyst. Initially, in the conventional method, organic reagents were utilized. Later on, the development was taken place, and then the metal catalysts are utilized, and nowadays also it is utilized. And if we go further, nowadays the nano material is utilized as a catalyst. So this is the one of the best way for the greener concept. Now this catalyst involves the homogeneous catalyst and homogeneous catalyst. Along with that, the nature has given the catalyst, that is the enzymes. So here this is the standard reaction, that is a conventional reaction that is given for the formation of the desired product. But if you look at when the acetophenone is reacted with the NaBH4 followed by the hydrolysis, it produced the BH3 and NOH, that is the strong base, along with the product. But same reaction can be carried out by using the reduction as a PD catalyst. So it is the catalytic reaction. So acetophenone is reduced in the alcohol by using the palladium catalyst. So this is the conventional reaction and this is the green reaction. Another reaction, that is the acetylation of the methoxybenzene. So ultimately if you look at, it is introduce the acetyl group. So that can be carried out in the presence of the AlCl3 as a catalyst and CH3COCl acetyl chloride. But you are well familiar with the acetyl chloride. So this should be shifted in the greener approach. So in place of the acetyl chloride, it is recommended to utilize the acetic anhydride, and in absence of the AlCl3 catalyst, H-beta can be utilized to get the desired product. Here also that HCl is produced along with the product. Here acetic acid is produced. So acetic acid is more safer than the HCl. The desired material should be degradable. Then and then the environment will remain safe. So can be utilized any of the degradative method, but the end molecule after the degradation, that should not harm to the environment. It is important to observe the real-time analysis. So analysis can be performed inline, online or at line, so that it can minimize the byproduct. So during the reaction process, during the production, the analytical chemist or supervisor must be online to minimize the pollution. Now this is the last principle. We could say that it is the safety principle. The intention of this principle is to avoid the accident. So it is required to understand the design of chemical form, physical form of the compound to minimize the explosion or fires or related to the environmental issues. So safety can be defined as the control of recognized hazards to achieve an acceptable level risk. We have seen the 12 principles of green chemistry, and also we had seen the green solvents and the green reagents. Now I am talking about the green catalyst. So this is the one of the very foundation aspect to carry out the reaction in green environment. So green catalyst is the eco-friendly catalyst. It can be regenerated or reused multiple times in the chemical reaction. So ultimately it produces the minimum waste. So during the chemical transformation, it required the minimum quantity of the catalyst, and that is why sometimes the scientists are saying that the catalyst is the foundation pillar for the green chemistry, because it reduces the quantity of the catalyst, it reduces the energy, also it is easy to separate, and also the selectivity is increased. So it is advisable to utilize the catalyst, green catalyst, nano catalyst in the chemical reactions. Now, the catalysts are basically of two types, that is the heterogeneous catalyst, that is also known as the contact catalyst, or you can say surface catalyst, because it is directly dealing with the surface of the catalyst. And another type is the homogeneous catalyst, because the phase of the catalyst is same as a substrate. So here it is the basic difference of the heterogeneous catalyst and homogeneous catalyst is given. Both are having the advantages and disadvantages, but the heterogeneous catalyst is more suitable because it is having the distinct solid phase, or it is easy to separate out, where the homogeneous is often difficult to separate. The heterogeneous is sensitive to poisonous. Here it is the robust to poisonous in the homogeneous. In the heterogeneous catalyst, the selectivity is lower, but in the homogeneous, high selectivity factors can be considered. So if you go through the different factors and if you go to the detailed study, you will able to find that heterogeneous catalyst is more safer. Now, to use the catalyst, these are the few methodology discussed here to carry out the organic synthesis, and that should be the green. So it should be the phase transfer catalyst or ionic liquids, or can be utilized the microwave induced green synthetic reactions or aqueous phase reaction or organic synthesis in the solid state, or by utilize the ultrasound assisted green synthesis. So these are the advantages of the phase transfer catalyst. So higher productivity of the product, higher selectivity, ease of the product separation, and uses of the less hazardous solvents in the presence of the phase transfer catalyst. These are the few examples of the phase transfer catalyst. So epoxidation of the alkanes, or you can say the oxidation of the benzene to phenol, or oxidation of sulfide to sulfones, can be carried out by using the phase transfer catalyst. This is the very simple example that is given by using the phase transfer catalyst. So the reaction of the cyclohexane in presence of the chloroform and the NaOH, only 0.5% product is formed in the absence of the catalyst. But when the phase transfer catalyst is utilized, the yield is increased from 0.5% to 60 to 70%. Another methodology is the microwave induced green synthesis. In that, it can be carried out of two types, that is microwave assisted reaction in water, and second, that can be the solvent free reaction. Here, very simple example of microwave induced reaction is taken, and that is the nitration. So we are well familiar with the conventional method of the nitration. So nitration can be carried out in presence of the concentrate HNO3 and H2SO4 to produce the nitronium ion. So phenol is nitrated and form the paranitrophenol by using the concentrate HNO3 and H2SO4. But the same reaction is carried out in presence of the microwave energy and in the presence of the copper nitrate. So phenol is nitrated in presence of the copper nitrate and acetic acid. It required only 1 minute to form the desired paranitrophenol product. Whereas in the conventional method, it takes around 1.5 hours. Here in microwave, it takes only 1 minute. So energy is saved. Here the another example we have taken, that is the deprotection of the methoxy group, or it can converted into the phenol. So this is the condition for the conventional method and this is the condition for the green method. So microwave device is utilized to carry out this reaction. So what is the major difference you can notice here is, in the conventional method it required the 72 hours, but in the green method by using the microwave radiation it required only 5 minutes. So these are the best example to discuss the green synthesis by using the microwave radiation. So here we will take the very simple example, that is the Cannizzaro reaction. This is the conventional method of the Cannizzaro reaction, in which the benzaldehyde, 2 moles of the benzaldehyde is condensed in presence of the strong base for around 2 hours to form the benzoic acid and benzyl alcohol. So that we are performing in the laboratory. But now in the green method, we are not utilizing the strong base. We are utilizing the barium hydroxide, that is weak base. In the conventional method, it was taking 2 hours to form the benzoic acid and benzyl alcohol, but here it takes only 10 minutes. So within a 10 minutes, the product is formed. In the conventional method, around 70% yield is obtaining, whereas in the ultrasound method, in green method, it goes up to 100%. Another example of the green is carried out in the aqueous phase. So it is the type of the aqueous phase reaction. So this is the Novangel condensation reaction, where the ketone or aldehyde gets converted into olefinic compound. So conjugated enone is formed by using the ketone, active methylene, and the base, that is the piperidine. Now same reaction is carried out with the aqueous phase, in which the water is utilized as a solvent and reaction is carried out within very short period of time and gives the product around 95%. So this is also another concept to carry out the reaction in aqueous phase. The basic question is here that why do we go green? So if you look at the history of India and world, lots of chemical accidents are taken place. The famous example in India is the Bhopal tragedy taken place at the Bhopal in 1984 on 3rd December, where methyl isocyanide gas was leaked and around 3,500 people died immediately and 15,000 people were died later on due to the poisonous gas, that is the methyl isocyanide. So what was it? So they have utilized the phosgene with the methylamine, and during the formation of the product, methyl isocyanide was produced and this gas was leaked and it was converted into number of deaths. So this is the conventional method, but the alternative is by using the phenol in presence of the COCl2. With the step of the reaction, same product is formed. But the difference is here in this method, the methyl isocyanide, that is the poisonous gas, is not formed. Very recently, during the lockdown, in the month of May, Vizag gas leak tragedy taken place, where the few people were died. If you look at the world, so many accidents are taken place so far. So that is why the green concept is. So now we will discuss how to go green. So one of the concept already we have said, that is by using the nanomaterial, nanoparticles in the organic synthesis. So we have discussed the homogeneous catalyst, we have also seen the heterogeneous catalyst, but here due to the high activity, high selectivity, excellent stability, easy to separate, it is also energy efficient and atom economy. Due to this reason, we are going to use the nanocatalyst in the organic synthesis. For synthesis of the nanoparticles, two basic methods are utilized, and in our work also we have utilized these two methods, that is the top down approach and bottom up approach, with which it is possible to synthesize the nanomaterial by both the method, that is the top down and the bottom up approach. So here we have utilized the sol-gel method for the preparation of the uniform nanoparticles. So in which The pictorial presentation of sol gel method is mentioned here. So it is utilized to prepare the dense film type nanomaterial. It is utilized to prepare the bulk nanomaterial. Sol gel method is also utilized to prepare the aerogel and also for the uniform nanoparticles. So this method is utilized to synthesize the nanomaterial in our work. Now, once the nanomaterial is synthesized, now it is required to have the support, because this provides the surface. So supported metal nanocatalyst is required. So type of the supported material is like metal organic frameworks, MOFs, or carbon materials, activated carbon, carbon nanotubes, graphene and graphene oxide. One of the student under my guidance, he is working on the graphene and graphene oxide. Then the natural polymer, synthetic polymer, clays, metal oxide, zeolite, and graphitic carbon nitride and boron nitride. So these are the supports utilized for the nanomaterial. So we have utilized the carbon nanotubes as a support. We have also utilized the natural polymers as a support. The synthetic polymer is also utilized as a support, and the graphitic carbon nitride and boron nitride is also utilized by my research group.
Here it is the few example where the application of supported nanocatalyst are utilized in the organic synthesis. So if you look at this, it is the type of the A3 coupling reaction where supported silver nanoparticles are utilized. In the second reaction, again it is the supported Ag nanoparticles are utilized. In the third reaction, it is the homocoupling where supported Ag, Pd and Cu nanoparticles are utilized with the different conditions. Here in this another example, again the supported nanomaterial is utilized, that is the copper nano particles. Then the other nanoparticles are utilized. Here it is utilized the Fe nanoparticles. Here the nanomaterial is also utilized, as well as the PD catalyst is directly also utilized. So both the things are possible. Conventional method also, and with the same product is obtained by using the nanoparticle as a catalyst. Here few more examples of it is given, where the supported palladium nanoparticles are utilized with the base. Here gold nanoparticles are utilized. Here again the copper, gold, palladium nanoparticles are utilized. So all these reactions you have seen, that is of the CH activation by utilizing the different nanoparticles, and the different supports are utilized. Here few examples of the famous name reactions are given, where Hiyama coupling reaction, Suzuki coupling reaction, Heck reaction, Sonogasira coupling. So these are the famous name reaction that is given by the conventional reaction, but that same reaction can be carried out with the support of the any of the nano catalyst. So here in the Hiyama coupling reaction, scientist has reported the reaction by taking the palladium and gold nanoparticles as a catalyst. Suzuki-Miura coupling reactions are also reported in the palladium and gold nanoparticles. In the same way, Heck coupling reaction and the Sonogasira coupling reaction. So these are the famous name reaction based on the palladium catalyst with the different base, but here it is reported with the different nano catalyst utilized, and that is the ultimate goal by using the nanoparticles. By looking to the previous reaction as discussed so far, it is very important to develop the carbon-carbon new bond or carbon heteroatom like CN-CS-CO bond. And it is also very important to use the greener approach. So the scientists are interested to develop the new compound that are utilized in the medicinal chemistry or pharmaceutical chemistry or in polymer chemistry. So due to the generation of the CC linkage, it is also possible to introduce to the desired functional group. So here we have reported the sum of the new molecules along with the functional group. This work is published by my research group. We have prepared propylgylamine and 1,3-butadiene by using the graphitic supported Ag nanoparticles, and that is published in the Chemistry Select. You may refer this paper. It is available in the Chemistry Select where it is published. Carbon nitride and the graphitic carbon nitride is synthesized by the reported method, and later on it was synthesized graphitic supported silver nanoparticles. The synthesized graphitic carbon nitride Ag nanoparticles, that is the catalyst that we have utilized, that was characterized by the SEM analysis, HRTEM analysis, EDX, XRD and IR. So any of the nanocatalyst can be characterized by these techniques. So here in this work we have confirmed the catalyst by these techniques. SEM analysis is utilized to study the surface morphology. So here this is the SEM analysis of Ag nanoparticles supported on graphitic carbon nitride. So here in the figure A, it is the same images of the graphitic carbon nitride. It looks like a flower. Now when Ag nanoparticles are doped on the supported carbon nitride, so the rough surface is seen, that is the figure B. So here it confirmed that the Ag nanoparticles are doped on the support. Now here it is the XRD analysis of graphitic carbon nitride and Ag graphitic carbon nitride is given. Now XRD is utilized to confirm the crystalline structure of the material and also the size of the nanoparticles. So here the figure showed a broad hump at 2 theta value at 27, which the XRD pattern of the graphitic carbon nitride. It can be clearly observed that typical XRD peaks of the graphitic carbon nitride can be seen, and all the diffraction peaks are in good agreement with the hexagonal nitride carbon structure, which is accordance to literature. The strong XRD peak at 27.50 is originated from the 002 interlayer diffraction of graphitic like structure having the good agreement with the reported data. The X-ray diffraction displayed the Bragg's peak at 38.43, then 44.08, 64.66 and 77.40, conferring the 111, 200, 220 and 311 facts of the face-centered cubic symmetry of the silver nanoparticles pattern, and that is also compared with the standard pattern. So here it can be confirmed that the silver nanoparticles are crystalline in nature, and it is also indicate that the size of the silver nanoparticle is calculated around 6 to 12 nanometer. The calculated particle size, that is the 6 to 12 nanometer, is having the good agreement with the analysis of the HR-TEM of the silver nanoparticles. So here it indicates the size of the nanoparticles, and that is 6 to 12 nanometer, and that can be confirmed by the HR-TEM analysis. Now here EDX analysis of Ag nanoparticles doped on the graphitic carbon nitride is given. The peak arise at 3 kilo electron volt indicates the presence of the Ag nanoparticle, and that can be supported by the AES, and it was found that the catalyst was doped around 0.0611 millimole per gram. And finally, that catalyst was also confirmed by the IR analysis. Now here it is the synthesis of the propyl amine. Now this method is the conventional method, whereas this method is reported by us. Now in the conventional method, different metal catalysts are utilized. In this we have utilized the silver nanoparticles doped on the graphitic carbon nitride. Here in the conventional method, around 120 degrees Celsius temperature is reported, whereas while optimization of the reaction, it was reported at 80 degrees Celsius temperature. Not only that, the conventional method is indicating that it required 24 hours to complete the reaction with 84% yield, whereas here we have reported the 97% yield of the propyl amine within the 20 minutes. So here there is a study given. The yield is obtained around 97% at the 20 minutes, whereas it required only 200 milligram catalyst. And also this 97% yield is reported at the 80 degrees Celsius temperature. Same way, the terminal alkyne is utilized, and with the CC coupling, the homocoupling of terminal alkyne is taking place. And this is the conventional method where it was taken the around 120 degrees Celsius temperature, but same thing was reported by us where it required only 80 degrees Celsius temperature and 200 milligram catalyst, and 98% yield is reported by using the Ag nanoparticles. This is the possible mechanism of the homocoupling reaction of the terminal alkyne. The recyclability of the catalyst is the key factor of the heterogeneous catalyst. So here the catalyst is recycled after the reaction, and it gives the effective result till the 7 run. After the 7 run, the activity of the catalyst is slightly decreased. Here the post reaction TEM investigation is given. So TEM analysis of the post reaction after 7 run is taken. So less Ag nanoparticles are lost during the reaction. And finally the product propylgyl amine is produced, that is confirmed by the 1H NMR, and the homocoupling reaction was taken place, and that also was confirmed by the 1H NMR and the mass spectra. In the same way, our research group has reported this work recently in 2020, the synthesis of the Y-non by using the Ag nanoparticles doped in the graphitic carbon nitride. So here this work is just carried out in the visible light, and this work is published in the Chem journal with the 4.5 impact factor. Now Y-non is utilized to synthesize the different heterocycles. So in the literature all these heterocycles are reported from the Y-non. So we have reported this Y-non by using the Ag nanoparticles. To synthesize the Y-non, homogeneous catalyst is utilized in the literature. Now we have reported the Y-non, synthesis of Y-non by using the Ag nanoparticles doped on the carbon nitride by using the triethyl amine. But here we have utilized the visible light. We have used the 80-watt tungsten filament bulb to complete this reaction, and it was reported up to 84% yield of the Y-non. The recyclability study of the Ag nanoparticles is also given, where after the 3rd run the activity of nanoparticle is slightly decreases, and in the 4th run it gives around 81%. Not only that, the same reaction was carried out on the gram scale. The 78% yield is reported with the catalyst, and the post reaction of the TEM, XRD and XPS studies also. The synthesized Ynon is confirmed by the 1H NMR as well as the mass spectra. Again here the another work is reported by our research group, where it is also the coupling reaction, but here we have utilized the polystyrene as a support and copper nanoparticles are utilized. So this is the method to generate the polystyrene supported copper nanoparticles, and that catalyst was studied and characterized by the FTIR, then the SAM analysis, TEM analysis, XRD analysis, and the Raman spectra as well as the EDS spectra of the copper nanoparticles. Now, this reaction is reported in the homogeneous catalyst, where yield was very less and temperature was high. Also, the solvent was utilized. We have reported the same work in the microwave heating at around 80 degrees Celsius temperature. The catalyst is utilized only 100 milligram. But the beauty of this work is this is the solvent free reaction, and we got around 78% yield. So this is also good example of the solvent free reaction. Also the recyclability of the catalyst is studied, and the activity of the catalyst is slightly decreases after the 7th run of the reaction, and the product was also confirmed with the spectral analysis. Very recently, we have also reported the another work in the chemistry select, that is the Sono-Gashira coupling reaction, where copper nanoparticles are utilized and support is taken as a polystyrene resin matrix. By the series of the reaction, XID16 resin that support is synthesized, and this was the stepwise photograph of the synthesized resin, and that is utilized in the optimization of the reaction for the formation of the Ynon. Now here I can conclude this session. We have synthesized the different nanocatalysts like Ag nanocatalyst, copper nanocatalyst, and the palladium catalyst, and that catalyst is doped in the different supports, and the synthesized catalyst is characterized by the various techniques like SAM, HRTEM, EDX, XDS, XPS, and IR spectroscopy. It was found that the heterogeneous catalyst was utilized and yield was achieved up to 98%. It is also found that the recyclability and the reusability of the catalyst. The synthesized catalyst is easily utilized up to 7 to 8 runs with good stability. Now the synthesized nanoparticles are having the size between 6 to 12 nanometer. The beauty of this work is the quantity of the nanoparticles are utilized very low, and that is around 0.06112 0.0531 millimole per gram. Along with that, the different factors are also studied like E factor, atom economy, tone and TOF factor. So here I can say that we have applied the green chemistry principles, and it was these reactions are the energy efficient and environmental friendly. So I thankful to Gujarat University. I also thankful to Department of Chemistry, Gujarat University. My special thanks to my research group, Nikita Mishra, Sheetal Patel, Tejas Shah, Sunil Patel, Himanshu, Dinesh, Siddhi Panchal and Rusvi Gandhi for their constant and selfless support. Thank you so much. If you are having any query, any doubts, please feel free to communicate on my WhatsApp number or the email given to you.